This story goes back to 2006, when scientists around the world picked up something unusual in our atmosphere, a dangerous gas called methane. They noticed that the amount of methane had suddenly shot up, and it's still rising today. Methane is a type of natural gas that once released into the atmosphere, traps heat around the planet, kind of like throwing a blanket over yourself in winter. That trapped warmth can't escape, so Earth heats up even more. In fact, methane is far more effective at warming the planet than carbon dioxide. When this spike was first spotted in 2006, researchers thought human pollution was the cause. But the deeper they dug, the stranger it got. What they found shocked them. This was a hidden secret Earth had been holding on to. So how exactly was all this methane being produced? Why was it climbing so fast? How do scientists even detect it? And most importantly, is this a sign of the planet heading toward collapse, or the start of some huge climate shift? Welcome back to another video from ZimVoice. Scientists already knew methane spikes in the atmosphere aren't random historically. They happen roughly once every 100,000 years. How do they know? By drilling deep into the ice sheets of Antarctica and Greenland to pull out ice cores. Here's how it works. Imagine Antarctica gets about a meter of snowfall every year. Tiny bubbles of air from that year's atmosphere get trapped in the snow. The next year, a new layer of snow seals it in. Over thousands of years, those layers stack up like pages in a history book. When scientists drill down and pull up a core, they're holding a frozen time machine, preserving samples of air from thousands, even hundreds of thousands of years ago. Studying these layers reveals which gases were present in the atmosphere and in what amounts. That's how researchers discovered that in Earth's history, once every 100,000 years or so, methane levels rise sharply. And whenever that happens, it signals the end of an ice age and the start of a warming period. When an ice age ends, in just about 2,000 to 3,000 years, enough ice melts to create a climate much like ours today. But here's the catch. The last big methane peak happened 12,000 years ago, marking the end of the last ice age. So why are we seeing another spike now, so soon? Could this mean the planet is moving toward a major shift or facing a new kind of threat? To answer that, we need to zoom out and look at Earth's history. Right now, we're living in what's called the Quaternary period, which began about 2.5 million years ago and is still ongoing. This period has two parts. The first is the Pleistocene epoch, from 2.5 million years ago until 12,000 years ago. During that time, the planet cycled through repeated ice ages. Massive ice sheets would advance, covering much of the land, then retreat as the climate warmed. This on and off rhythm shaped human evolution and saw the extinction of giant animals like the woolly mammoth. The second part is the Holocene epoch, which started 12,000 years ago and continues today. This has been a warm, stable period. Ice retreated, agriculture took root, and humans settled near the fresh water left behind by melting glaciers. Now here's an interesting detail. Technically, we're still in an ice age. Why? Because ice sheets still exist at Earth's poles. The only time we can say an ice age is truly over is when the poles are completely ice-free. So what actually ends an ice age? Scientists point to three main factors, known as the Milankovitch cycles. First is eccentricity. The shape of Earth's orbit around the Sun changes from nearly circular to slightly oval over a cycle of about 100,000 years. This alters how much sunlight reaches the planet. Second is axial tilt. Earth is tilted at about 23.5 degrees, but this angle shifts between about 22.1 and 24.5 degrees over 41,000 years. More tilt means more intense summer sunlight at the poles, which melts ice faster. The third factor is precession. Earth's axis wobbles like a spinning top over 19,000 to 23,000 years, changing the timing of the seasons. Together, these cycles can kickstart warming. Melting ice exposes darker land or ocean water, which absorbs far more sunlight than bright, reflective snow. This accelerates melting. As the planet warms, gases like carbon dioxide and methane trapped in permafrost or under the sea floor are released, making the planet heat up even more. So, if that's the natural cycle, why the sudden surge in 2006? The last Ice Age ending event was just 12,000 years ago, not 100,000. Back in the early 1900s, the rapid growth of the natural gas industry caused human-driven methane emissions to rise. But by the 1990s, those levels had plateaued. Then suddenly, 2006 brought a sharp new jump. Methane, remember, isn't only from human activity. It's also created naturally, stored in wetland soils, ocean floors, and frozen permafrost. When permafrost thaws, ancient plant and animal remains decompose and release methane. With modern tech, scientists can now pinpoint methane sources from space. They use satellites that fire laser beams at specific wavelengths, ones that methane absorbs. If the beam doesn't bounce back, that means methane is present. Using this, scientists have mapped methane hotspots across the globe. NASA teams found one in Iran, a massive landfill producing a methane plume 3 miles long, releasing over 73,000 tons each year, about the weight of 180 jumbo jets. That's 8,500 kilograms every single hour. But even that's topped by Turkmenistan, where oil and gas sites are releasing around 400 kilograms per hour from multiple locations. And yet, experts say these sites explain only part of the post-2006 spike. The larger share is coming from thawing permafrost under forests. Once that ground thaws, methane trapped for thousands of years escapes, and unlike landfills, there's no practical way to capture it. Some advanced landfills actually collect methane and use it to generate energy-producing carbon dioxide as a byproduct, which is still harmful, but far less potent than methane. Methane lingers in the atmosphere for about a decade before breaking down into CO2 and water vapor. But here's the worrying part. Yes, Earth has seen high methane levels before, like 12,000 years ago, but that was during a known ice age ending. This time, glaciers are already much smaller, and yet methane is climbing again. That's something we've never seen in the geological record. This could mean Earth is heading into an entirely new phase, but predicting which way it will go, full ice age end, or a swing into a new ice age, is tricky. We don't have a historic example of methane rising this much, this soon after an ice age peak. And if this is natural, not human-driven, stopping it might be impossible.